So I'd like to continue talking about biological hazards and the number of deaths for leading causes of death in the United States and the world. In terms of globally, the list of the top 10 causes of death are depicted in the graphic on the right-hand side. Of the 56 million deaths worldwide in 2015, more than half, about 54%, were due to heart disease and stroke. Combined, these two account for about 15 million deaths globally in 2015. And these two categories have remained the leading causes of death globally in the last 15 years. For the United States data, it's listed here on the left. Heart disease is the #1 cause of death in the U.S., followed by cancer, which is then followed by chronic lower respiratory diseases, accidents or unintentional injuries, followed by stroke, then Alzheimer's and diabetes and flu. So it does vary on a global scale as to what the top 10 causes of death are versus what happens here in the United States. Jumping back to cancer, that's a generic term for a large group of diseases that are characterized by abnormal growth cells beyond their usual boundaries that can then invade adjoining parts of the body and spread to other parts of the body. Malignant tumors are often associated with the word cancer. Cancer can affect almost any part of the body and has anatomic and molecular subtypes that require specific management strategy. Lung cancer, prostate cancer, colorectal cancer, stomach, and liver cancer are the most common types of cancer in men, while breast, colorectal, lung, cervix, and stomach cancer are the most common cancers in women. So this chart definitely depicts a lot of data, and you may be asking the question, why do we even need to know the reasons why people die? Well, measuring how many people die each year and why they died is one of the most important means, along with gauging how diseases and injuries are affecting people, for assessing the effectiveness of a country's health system. Cause of death statistics help health authorities determine the focus of their public health actions. A country in which deaths from heart disease and diabetes rises rapidly over a period of a few years, for example, has a strong interest in starting a vigorous program to encourage lifestyles to help prevent these diseases. Similarly, if a country recognizes that many children are dying of pneumonia, but only a small portion of the budget is dedicated to providing effective treatment, it can actually increase spending in this area to prevent the impact on children with pneumonia. High-income countries have systems in place for collecting information on causes of death, and therefore can evaluate the health of their country. Many low- and middle-income countries do not have such systems in place, and the number of deaths from specific causes have to be estimated from incomplete data. Improvements in producing high-quality cause-of-death data are crucial for improving health and reducing preventable deaths in these low-income and middle-income countries. So really, we track this data in order to determine what needs to be focused on to decrease the number of deaths that are occurring from transmissible and non-transmissible diseases, and what kind of programs can be put into place and what funding can happen in order to prevent these diseases. This is just a graphic that depicts around the world what the primary cause of death is in each of the countries. Notice that for the United States and Canada and for much of Europe, as well as Northern Africa and Australia, it's heart disease. Cancer is depicted in an aqua blue, and there's some countries in Europe that have throat and lung cancer, as well as China, it's liver cancer. That's the main biological hazard in that region. The red color depicts areas where HIV and AIDS is the predominant cause of death, and you can see that almost 3/4 of Africa is depicted in red, and even some countries in South America is depicted in red as well. And then tuberculosis is also depicted in the dark blue. So this graphic gives you a real quick glimpse of what the primary cause of death is within the various countries depicted around the world. So we've talked about natural hazards and biological hazards. Now we're going to shift gears to chemical hazards. We've defined the term pollution in the past, but just to bring it back to your memory, it's the presence of a substance in the environment that, because of its composition or quantity, prevents functioning of natural processes and produces undesirable environmental or health effects. A pollutant is described as any material that causes pollution, and it's usually a byproduct of some desirable action like manufacturing or industrial process, as well as it can come from agriculture and transportation sectors. Pollution has increased due to population increase and consumption increase. So, looking at the graphic in front of you, the diagram on the right shows different sectors of pollution, including air pollution, water and land pollution. And you'll notice it's broken into subcategories. Under air pollution, there's particulate pollution, acid-forming compound pollution, photochemical smog, and carbon dioxide emissions, which contribute to global warming. Then you also have CFCs in the air pollution category as well, which contributes to ozone depletion. In the land and water category, you have sediments, which are considered a pollutant, nutrient overload from farms and sewage treatment plants are considered pollutants. Solid waste is considered a source of pollutants, such as from landfills or waste-to-energy facilities that burn garbage. And then we have a category for toxic chemicals that are sourced from spills of toxic chemicals or leaching from disposable sites like a landfill or being discharged from an industry. And there's also a separate category identified for pesticides and herbicides as well. So, these different chemicals get into the air, into the land, or into the water, and we as humans can be exposed to them through different ways. Different pathways. One is ingestion, actually consuming the contaminant, and that could be because the contaminant has become a part of the food that we eat. Another way is through breathing in the contaminant or the pollutant in the air. And another way is getting the contaminant or the pollutant directly on your skin. So those are the three pathways of exposure: ingestion, breathing, and direct contact on skin. So the other thing is that human exposure to a hazard and the pathway of exposure is very key to determining what the risk associated with that chemical is. People can be exposed to chemicals in the workplace, as well as just in general their living space that they reside in. It's important for you to understand the term dose. That's the level of exposure multiplied by the length of time of exposure. So chemical waste and byproducts are inevitable. Many thousands of chemicals are produced each year in industrialized nations, and in the U.S. we are an industrialized nation. Here we have over 80,000 chemical substances registered in the United States that are used commercially. About 10% of these chemicals have been thoroughly screened for toxicity. So that's not many. That's about 8,000 chemicals. Only a small percentage, 2% of the commercial chemicals, actually are identified as posing a risk to humans. But please keep in mind that's only because a small percentage, i.e. 2%, have been adequately tested to determine their toxicity effects on human health as a carcinogen, a mutagen, or a teratogen. So there's still a lot that we don't know about the existing chemicals that are currently being used. There are over 8,600 different food additives, 3,400 different cosmetic ingredients, 35,000 different types of pesticides. The National Academy of Sciences notes that fewer than 10% of our U.S. agricultural chemicals, mostly pesticides, have been fully tested to assess long-term health effects. And 5% of our food additives have been fully tested to assess long-term health effects. So basically, we've got these different chemicals that are out there and available for use, as well as being released into the environment and potentially being in our food, that we haven't had complete testing done to determine the long-term health effects of them. Part of the reason for this is because testing potentially harmful substances is a very costly and time-consuming task. It's also made more difficult by the 700 to 1,000 new chemicals entering the marketplace each year. It's important to know the different laws that have been passed regarding chemicals and the environment. And the first one I want to highlight is the Occupational Safety and Health Act of 1970. Industries used to force workers to do jobs that exposed them to hazardous materials without informing them of the dangers involved. After this law was passed in 1970, it now requires that businesses and industries and labs make information available to the workers about the hazardous materials that they're working with. This is done by using material safety data sheets, which is depicted in the bottom right corner of your screen, for every chemical that that employee could be working with on the job site. Also, the employers are required to provide suitable protective equipment, such as what's shown here in the top right picture. The Emergency Planning and Community Right to Know Act, or EPCRA, was passed in 1986. It requires that industries have to report the storage, the use, and the release of hazardous substances to the federal, state, and local governments. This applies to any industry or company that handles more than 5 tons of any hazardous material. This law also requires that the information about the storage of hazardous materials are provided to the local, state, and federal level so that they can provide emergency planning, emergency release notification systems, hazard chemical storage reporting, and toxic release information. So it's really to guard against any accidents and releases, and to make sure that emergency response crews are safe if they come on site to fight a fire or address some other incident. Those emergency response crews need to know what's being stored on site in order to protect them from any further injury. The Pollution Prevention Act of 1990 was passed, and that also mandates that companies focus on reducing pollution through cost-effective changes in their production operation as well as the raw materials that they use. Another term associated with pollution prevention is called P2, or source reduction. Another law that was passed is called FIFRA, or the Federal Insecticide, Fungicide, Rodenticide Act of 1996. This requires that all pesticides must be registered, and the companies have to prove that the pesticides will not cause unreasonable adverse impacts on the environment. The registration process for pesticides requires that the ingredients of the pesticide be provided, the particular crop where it will be used is referenced, the amount, frequency, and timing for its use be specified, and the storage and disposal practices be provided as well. And this all has to be put on the label to assure that it's being utilized properly. Other laws that were passed that are somewhat related to the FIFRA law include the Federal Food, Drug, and Cosmetic Act, or the FFDCA. This law requires to set pesticide tolerances for all pesticides used in or on food, or in a manner that would result in a residue in or on food or animal feed. In 1996, the Food Quality Protection Act was also passed, which provides strict requirements in regards to registering pesticides and doing reviews of those pesticides to assure that they don't pose any kind of environmental or human health harm. Another law that was passed in 2003 was titled the Pesticide Registration Improvement Act, and this basically also amended FIFRA and the FFDCA law, and it was basically to set up pesticide registration improvement requirements based on the previous law that was passed, and just to make things better for assuring that the registration process was appropriate and adequate to protect the environment and human health.